All right, here we go. Most of you don't know me, and I believe, well, that's good in this way because, of course, the line of business I'm in, it's not really too well known. What I'm working on is the Contextual City. What do I mean by that? Context is something that is all around us. If now there's, let's say, a Pokemon hidden here somewhere, if there is a great event happening somewhere around, everything that is around you basically is the context, and what we are creating is a layer between the real world and the internet at the end of the day to bring exactly this context to everyone, to all the different people that live in the city. We have APIs for that, we have a couple of apps, and of course what we are focusing on specifically here is events, right? Because events are great possibilities to meet up with people, to learn something new, to really experience something that you have not experienced before, or even meet someone you have never met before. So what has this now to do with AI? Of course, AI is something that, we generate a lot of data with that, right? The company exists now since 2013. We now launched this app, Drop-In, at the beginning of 2016, which basically does nearby events happening now. You refresh the app somewhere on this planet, and it recommends to you an event that's happening somewhere nearby. You can see there's a strong focus on the US market and parts of Europe. We are right now having around 2 million events on this platform, and that means anyone on this planet, if you refresh the app, you get a event recommendation for you delivered instantly. It's on-demand events. Yeah, very fascinating. I can see that. Of course, there's a lot of problems now with data. You have a lot of data now that is generated in the systems. You need to be able to understand this data, model this data, work with that data. And of course, we can recommend stuff with all this information we have. We can say, where should you hold your next event, right? So let's look at Singapore, right? For Singapore, there are currently around 2,000 event locations, which are coffee houses, airports, the Kallang Sports Center. It's really, all over the place. You can see it's going from Woodlands to Jurong to Changi. But there's a very strong focus, and I hope the red button is it, of course, in the CBD, right? If you now look at the user pattern, and we just selected now 10,000 random samples from our map, you can see that, of course, there's, in Tuas something, some Malaysia, something actually happened in Indonesia as well. But most of the stuff happens, of course, in the CBD, which is somehow clear, right? If you look at that, the event locations are in the CBD, that, of course, there is a location bias towards that. If it's nearby events happening now, that it's happening in the same area, right? So, of course, this is happening at the same place. So now, if you look at this, what can you do with it? You want to actually, cluster it, right? So in order to do reporting, in order to do recommendations, in order to understand now, let's say you're in the CBD and it's raining, what should we recommend? Should we give you, there's an umbrella store next door, or should we recommend, swimming clothes, right? And that's, of course, what we need to understand. So how to model now this whole thing, right? And of course, the point about modeling, and especially for the clustering algorithms, is always that you need to look into what is the most simple approach. Because at the end of the day, you need to understand what exactly are you modeling, what is going on, how is your business going to work, how is the data going to work. And the simplest approach always works the best, right? Let's say you're modeling car values, then of course the more you drive a car, the less there are simple rules in this world that just work, right? And of course, this is what we're going to do now. For our approach, of course, for the clustering, there are many methods to now do the clustering, but traditionally you can do two things. You can, of course, in the blue corner see the k-means algorithm, and in the red corner you can db-scan algorithm, which are two well-common or well-established algorithms to do geospatial clustering, right? K-means, and here, of course, you see the variance problem that was mentioned before already, is trying to minimize that, not too much on the bias. You need to give in the algorithm k-means the number of clusters that you want to get out of it. It measures Euclidean distance. What is Euclidean distance? Just, well, basically on a flat plane, the difference between these 2 points that you will have, and you will get an even cluster size. The dB scan, on the other hand, is a density-based cluster, and you will see the results coming up in a second what that means. It works on the Haversine distance, which for geospatial is a big difference, actually, compared to the Euclidean. It works on non-flat geometry, which is exactly the Haversine problem, and you don't need to give it a number of clusters. It will give you the number of clusters back, right? So now, which one do you think would work better, right? Now let's starting with the data points for the k-means. You see, well, it distributes quite well, right? You have here in the Water-Chouchuankang region, you have a lot of data points. You have the CDB is actually quite well clustered. You have this little ping point. You have the red points down here. You have Sentosa down here, and it looks like it would actually work quite well. But at the end of the day, this is what comes out with it. If you now look at the dB scan algorithm, you say, well, what did happen here? You get this one very big cluster right in the middle, smack here, which of course, it's the density problem. Then of course you have this little pink part here and you have the little red part here. So of course in theory now it looks like, of course, the dB scan algorithm performs much worse. So from the findings part, you can of course argue the dB scan, it makes this one big mass in the middle that doesn't really work well. But of course the problem is if you look now into these different regions, you're having a bias that your sample is only Singapore, right? So the moment in time you try to scale this and use now the same settings, the same algorithm for, let's say, Indonesia or Japan or Korea, suddenly all your work doesn't add up anymore, because suddenly you have a much larger geographical distance, and this whole impact of that actually the Earth is not flat applies to your problem. And it skews your whole, clustering, and so you cannot use your nice k-means anymore. So of course, the problem is Singapore is great, but it's just a small point compared to the rest of the world. So here you have in the model bias immediately given, because it's quite small what you have been modeled on. So at the end of the day, CBD, of course, is great, because that's the end where you would then create your event, because it is just close by. Most of the people are looking for events in that area. But, of course, your results may not be as good as you think it would be. So now for the model bias, how would you deal with it? Of course, you should not scale from the small sample to the large production immediately. You need to understand what makes your data work, right? So for this event situation right now, of course, you need to understand why people go to events and where people go to events. And with the data that you have, of course, if you cluster it correctly, you understand that in a much better way, right? Usually people are interested from a business point of view. So in the data, and that's basically now coming to the second point here, you need to include the domain knowledge if you now create your models in a better way. Because of course, not all events are modeled in the same way. Not all events are the same thing. Some are just meetups in a coffee house where you discuss American politics over a coffee or a beer. Other are let's say Guns N' Roses near Changi, or the Singapore Air Show with hundreds of thousands of people coming to visit. So of course these type of events matter, right? So here again you can update, you can change your model, you can influence this and create a better model with less bias for these events. And of course the timing of the events matters, right? Because at the end most events happen between 6 p.m. and 7 p.m. During the week, and interestingly between 11 a.m. and lunchtime on the weekends. So if you know that, of course, you pretty much know when you have to do your next event. So on a Thursday night, 6 p.m. is a good place near the CBD. That usually works out and attracts a lot of people. And we could easily see that in the data. And that is, of course, a model bias that you would then use for yourself. Of course, now, how can you work with that model bias? What are the steps against it? Of course, scoring is always something that is very close to my heart with that, because you need to make sure that you understand how good your your model is at the end. And I will not go into the details of scoring functions now, because it was mentioned before already. But at the end of the day, scoring is you get a very concrete value that explains to you how good your model is. And if you have this very concrete value, you can always measure against, improve your model. You can only manage what you measure. It's a very, clear and well-known sentence. But of course, this is how basically the model improvement then would work. Scoring is important, and that would be it from my side already. Thank you very much.